Question 5 is asking about renewable and non-renewable energy resources. And first of all, you're asked to define what is meant by the term non-renewable. Okay, so non-renewable resource is a resource that can't be replaced or replenished. An example of non-renewable energy resource, the main ones that you need to know are oil, natural gas, and coal. Okay, and you might argue, well, these can be replaced, but the only way that you can replace them is on a timescale of millions of years. So they're certainly not easily replaceable. Okay, just thinking about it, there's there is another non-renewable resource, which is nuclear. Obviously, uranium-235, when that gets converted to krypton and barium, that's used up, then it's not easily replaced or replenished. And looking at the next question, okay, how do we get that electricity from the remote wind farm to large cities? The first thing that sprung into my mind is the national grid. So there we go, that's my answer. That's not going to score very highly though, is it? Because look, there's 3 marks here, okay, and I've only said one thing. So they're obviously looking for a bit more than this. And what they're looking for is, what happens to that power as it goes through the national grid. So the first thing is that it gets put through a step-up transformer. And now the reason for this is because if you're taking low voltages, let's say if you've got 100 volts, then if you were transferring that over very long cables, very long power lines, then the current in the power lines and the resistance of the power lines would mean that a lot of power got wasted. So what we do is we step it up to a very high voltage, and that means that we're using very low currents in the power lines, and that means that there's a lot less resistive heating. Yeah, so a lot less power gets wasted due to resistive heating in the power lines. But 300,000 volts isn't very safe for domestic users to use. So then the next thing that you need at the other end is a step-down transformer to get it down to a safe voltage for domestic usage, which in the UK and Thailand is about 240 volts. Okay, next question is asking you for the advantages and disadvantages of wind farms, and they're asking you to discuss. So that means that we want some advantages and we want some disadvantages as well. Okay, and it doesn't have to be an exactly equal number. You could do 3-3. I mean, personally, I find it easier to talk about the advantages of wind farms than the disadvantages, so that's what I'm going to go for. Okay, so number 1 is renewable, which means that it's an energy resource that doesn't get used up, it can be replaced. It's got very low running cost. Now, it's not just enough here to say that it's cheap. Okay, the low running cost is a much better answer. The wind farms aren't particularly cheap to build, but once you've built them, they've got very low running costs. I mean, the wind keeps blowing for free. You don't have to keep putting more wind in. They're very low, or indeed 0 carbon emissions when they're running, or if you looked at the building of them as well, they come in as very low carbon emissions. Therefore, it doesn't contribute to the climate crisis, which is a huge thing in its favour. Wind is an abundant source of energy. A large wind farm can have a very high power output. If each single turbine, might not be that high, but once they're all put together in a wind farm, you can get respectable power outputs from them. And then also, it can be good for the economy of remote places, jobs for the local economy into building it and maintaining it. There's 5. I'm sure I could have come up with some more, but I'm going to stop there because the question asked me to discuss. And if I just put advantages down, then that wouldn't be a discussion. So now I need to think of some disadvantages. Okay, so the wind turbines, can cost a lot to build. I think the payback time is typically about 8 to 10 years to pay back the construction cost of them. So it is an investment. Some people find them ugly. I don't. I think that they're beautiful. I'd love it if I could see one from my house. But some people object to them on the grounds of aesthetics and think that they're ugly. They only provide power when the wind blows. So this means that the output is not constant, and also that there's a limited amount of suitable sites where you can build them. Obviously, you want to pick sites that are windy.